Okay. You welcome, dear students. This is our next success call. The caller gives you all the A grades in your G.C.E. exams, both A levels and also ordinary level. This is the call that gives you quality results. Once you are on these videos, be sure to have all the quality results that you desire in the G.C.E, in the Cameroon G.C.E, both O and A levels. I am your host, Mr. Destin Emmanuel, and right away for today, we are going to solve June 2024 Engineering Science Paper 2. I will begin with section A. In section A, question 1. Question 1, as I read, it says, an experiment to determine the characteristics of a linear generator. A rheostat is used to vary the reading on the ammeter and voltmeter. The characteristics U equal to F of I is shown in figure 1 below. And in figure 1, let me sketch figure 1. We have a graph. Figure 1 is a graph. We have a graph of terminal PG versus measured in volt and also current in ampere. Here we have 0. And here at the top we have 9. Then somewhere here we have 8. And here we have a value of 16. And then you see there's a straight line. That leads and passes like that and crosses at 16. The straight line goes like that. Okay, that's I in ampere. Okay, now these points are plotted on this graph, and this graph points are plotted and this graph is drawn as you see there. And what we are required to calculate here is that we are to determine the EMF. We are to determine, that's number 1, the EMF. The EMF of the supply source that was used in that experiment, and also the internal resistance of the generator, that's small r. Okay, right away, dear students, you remember the formula that was given in class. In class, when this topic was treated, the formula of EMF given as the terminal voltage plus the current flowing times the internal resistance. And looking at this graph, you realize that this graph has a negative slope. And now is terminal PG that is plotted against current. Here is our terminal PG. This is also U, and here is our EMF. So, according to the way this graph has been drawn, we need to adjust this equation so that it should be like this, such that the terminal PG U can be equal to, we make U the subject of the formula, is going to give us the negative value of the current times the internal resistance plus the electromotive force, which is the EMF. Good. Okay, as this is gotten, the next thing now we want to do is to compare this equation. We can call this one, this equation we can call it 2. We compare it to the equation of a straight line. You realize that y is equal to mx plus what? Plus c. So you realize that the terminal voltage has been plotted against the current, and now meaning that the slope is actually the negative value of the internal resistance, and now the EMF is equal to the intercept. The intercept is the point where the graph cuts the terminal voltage axis. So from there you can, this implies that it can permit us to write that that's EMF is equal to the intercept. And now when we are here on the horizontal axis of the graph, we realize that when I is equal to 0, what will be the corresponding value of the terminal voltage? Is going to give us, when I is equal to 0, it means that minus IR is also equal to 0. And now the EMF will be equal to the terminal voltage, which is equal to 8 volts, where the graph cuts the terminal voltage axis. Okay, now the first quantity that was asked is the value of the EMF. So therefore, the EMF will be equal to 8.0 volt. That is already gotten. Then now we go to the next value that is asked. That's the internal resistance. Okay, the internal resistance here, we can use the graph now in order to get the internal resistance. You can see from the formula, from the slope is equal to the change in the terminal voltage over change in the current axis. Okay, this will imply that, let's go there. If you go there and you draw a big triangle according to the graph that is drawn, you will realize that here we have a value of 7.5. Here we have a value of 1.5. Then here we have a value of 2. Then here we have a value of 12.5 there. Okay, then I think all our coordinates are gotten. So we have now the slope, which is S, will be equal to change in the y-axis. We have 7.5 minus 1.5, which will be over the change in the current axis. We have 12.5 minus 2. This is going to give us, when we do this subtraction here, is going to give us here a value of 6. So on we have this by this, it gives us 10.5. So when you carry out that division, is going to give you, I think this is 12.12. So yes, when you carry out that division, it's going to give you a value of 0.5. We have 8 ohms, since it's internal resistance. Therefore, you come here. Therefore, small r will be equal to 0.58 ohms. So that is the value for our internal resistance. Meaning that question 1 is already solved. This is actually what was required from you.